All right. Okay, so this will be the first part of our lecture on the later members of genus Homo. We likely won't completely finish this lecture today. We likely will continue this into next week as well. Whoops, not sure what I did there. There we go. Okay, so just to review a little bit, as we transition from early members of genus Homo into later members of genus Homo, so essentially Homo habilis into Homo erectus. So some of the key features or changes that we're going to see in the anatomical features. So a flatter, more ornathic face. So remember the earlier forms, the Australopithecines and the pre-Australopithecines will have a prognathic face. So when you're looking at the crania and the mandible from a lateral view, you see that the midface and the jaw are projecting forward. So more ape-like. But as you get closer and closer to us, you're going to see a more vertical face. So when you look at it from the profile, it'll be much flatter, more up and down. Okay, the dentition overall is getting smaller, but also more generalized. So what we mean by that is that there's not going to be the significant difference between the size of the premolars and molars in comparison to the incisors and canines. Dentition is more generalized, indicating a more omnivorous, more generalized diet, which, as we're learning, is a good thing. The more different food sources we can utilize, the more adaptive we are if all of a sudden there's an environmental or climatic shift that makes one food source no longer available. The robust forms were an evolutionary dead end, most likely because their diet was way too narrow. They were focusing in on just rough, tough vegetation and tubers, and were not including a whole lot of other food sources in their diet. We do see the very first significant jump in cranial capacity. We saw a little bit of a jump with Homo habilis. In comparison to the Australopithecines, Homo habilis has a brain size between about 500 to 650 cc's. But with Homo erectus, we see that their cranial capacity is 800 to about 1100 cc's. We see some other significant changes. We see a commitment to fully obligate bipedalism. So when we're looking at the postcranial skeleton from the neck down, we see that Homo erectus has fully modern humerus to femur ratios. So meaning that the humerus, the bone in our upper arm, is shorter in comparison to the bone in our thigh, our femur. Our femurs also have that bicondylar angle. So our femurs angle inward towards our knees. We have that linea aspera on the back of our femur that allows for the attachment point of our muscles that are used for jogging and running and make us really good at persistence hunting. So thinking back to that film clip we watched last week of modern day hunter-gatherers. So remember, we're not necessarily faster than our prey, but we have greater endurance due to our locomotion, makes us have greater endurance when we're jogging and running, and also the loss of our body hair allows us to evaporatively cool through sweating. Homo erectus is also the first to migrate out of Africa into other regions of the old world, like the gates of Europe and also Eurasia. So they've gone global. Now, again, that doesn't mean that someday we won't find evidence that, the Australopithecines and Homo habilis made it out of Africa, but just based on what we have so far, Homo erectus is the first species that we see out of Africa. And of course, they didn't necessarily know that they were leaving Africa. They're just following the migration routes of the game that they're hunting and the seasonality of the fruits and veggies that they're gathering. So wider geographic range, much more sophisticated stone tool technologies. Homo erectus utilizes a tool technology called Acheulean tools. You may also hear those called hand faces or bifaces or hand axes. I'll show you a picture here in a moment. And then, of course, behavior-wise, we're seeing that Homo erectus is most likely controlling fire. It's possible that they're relying more upon their social group, that they're living in bands of nomadic hunters and gatherers, just like you see modern day hunters and gatherers depend upon each other for survival. They're entering into territories, meeting new predators, meeting new environmental circumstances. So it's very possible that they're needing to engage far more complex social strategies, and that the emergence of leaders is happening, and that social organization is becoming far more important and complex. All right, so here's those Acheulean tools that I was talking about. So when you're looking at this picture, they look kind of teardrop shaped. So it's this teardrop shape that you see here. And they're called bifaces or hand axes because there's two distinct sides. And so this teardrop shape that you can very neatly fit into the palm of your hand. Of course, I wish we were in person so I could pass these tools around, but these tools very neatly fit in the palm of your hand. And they were used for butchering meat and or digging up underground plant parts. So these tools were used to remove flesh from bone and also to dig into the ground to pull up tubers. Tubers are basically like underground potatoes. So in comparison to the Oldowan tools, so remember Homo habilis and possibly some of the Australopithecines utilized those very basic Oldowan stone tool technologies we talked about last week. But we're seeing with the emergence of Homo erectus, we're seeing a much more sophisticated strategic technique when creating their stone tools. Not that Oldowan tools don't have their own complexity in themselves, but with Homo erectus, we definitely see a jump in the sophistication of stone tool technology. We find evidence of Acheulean tools essentially wherever we find evidence of Homo erectus. We also find evidence that Homo erectus was processing animal bones. So it's likely that Homo erectus was hunting to some degree, but it was also scavenging. So it could be possibly kills that other animals, other predators had killed and then left behind some of the leftovers, and then Homo erectus is coming around and scavenging those leftovers. Okay, so with Homo erectus, with a greater inclusion of meat in the diet, we're seeing that essentially a lot of changes that are connected to this inclusion of more meat in the diet. It's possible that this allowed our brain size to become larger over time. Because remember, the brain is a very metabolically expensive organ. So it would have required that we consume high quality protein, or at least be able to have access to high quality protein and lots of calories. So it makes sense that we see a lot of these things happening at the same time: control of fire, sophisticated tools, migration out of Africa, and the gradual increase in cranial capacity. But all of this is being debated. The documentary that you're going to be watching this week, some of you may have already watched it. The Dawn of Humanity documentary is looking at Homo naledi, which is a very small-brained hominin that is also possibly engaging in some complex activities. This is also a very controversial topic. You may have seen it in the news recently, but we'll talk a little bit more about that once we get to Homo naledi. Questions so far? Feeling good? Okay. All right, let's move on to Homo heidelbergensis. So at home, practice saying this with me a few times. Homo heidelbergensis. Homo heidelbergensis. One more time. Homo heidelbergensis. So this is a species that comes after Homo erectus, but before the Neanderthals and Homo sapiens. So in general, heidelbergensis is considered to be the common ancestor of both Neanderthals and Homo sapiens. Now, of course, like anything else, it's debated. And Homo erectus is actually around coexisting with some members of Homo heidelbergensis as well. So it's, you don't necessarily want to think about it in a nice, neat line. But Homo heidelbergensis, in Africa and Europe, we see examples of these fossils anywhere from 600,000 to as recently as 130,000 years before present. And we see examples in Asia from about 200,000 to as recently as 130,000 years before present. So some of the very distinctive characteristics, so this is a Homo heidelbergensis fossil here. So really robust brow ridges, probably the most robust we've seen thus far, especially in this particular specimen, the Broken Hill specimen. So we see really robust double arch brow ridges, a cranial capacity of about 1,200 to 1,300 cc's. So just right underneath modern day capacity there. Slightly higher, more rounded skull, and smaller premolars and molars, so more and more generalized diet. Also, when you turn the skull to the side, very flat or gnathic face. So that's a very modern Homo sapiens-like feature. There's also, they're kind of considered a mosaic. So there's that term mosaic again coming up. So they're a mosaic of Homo erectus, Homo neanderthalensis, and Homo sapien-like features. So that's why sometimes they're considered to be the predecessors or the last common ancestor of us and the Neanderthals. They also have some pretty interesting behavioral characteristics. Their front teeth, their anterior dentition, their incisors, and their canines have wear patterns that indicate that they may have been using their anterior teeth as tools while making clothing. So essentially, they're using their teeth to hold down sinew, so a piece of animal hide, as they're using a tool to scrape away that excess flesh and make it into leather, into clothing. So tooth wear indicates that they're possibly using their teeth to make clothing, to make and to use tools. Very likely a very diverse diet. They were likely engaging in hunting, persistence hunting, but at the same time, they were also gathering fruits and vegetables, engaging in probably digging for tubers. They were likely eating about anything they could get their hands on. So, more and more diverse diet, including meat from big game animals. They likely had cooperative persistence hunting. And another jump in the stone tool technology, we see a tool technology called Mousterian tools associated with Homo heidelbergensis. And they utilize a technique called the Lavoie technique. And I'll show you a video clip of what that looks like here in a moment. But this is Homo heidelbergensis. So we see examples in Africa, Europe, and Asia. So migration out of Africa for sure. Indication that they were using their teeth as tools to make clothing. Another jump in the diversity of diet, more evidence for cooperative and persistence hunting, and another jump in the sophistication of tool technology. So here's some examples of fossils that are attributed to Homo heidelbergensis. So this is just another one of those summary slides that we've been doing. So this particular fossil is called Atapuerca 5. It was discovered at a site called the Pit of Bones in Spain. So Cima de los Huesos means the pit of bones. So this is a site in Spain. The features really heavy double arch brow ridges, relatively wide nasal opening. That's an adaptation to living in colder environments. We see that adaptation in Neanderthals as well. Large projecting mid-face. So they have what we call mid-face prognathism. So some of the earlier forms, like the Australopithecines, their prognathism is more in the mandible, in the jaw region. But when we get to, I wish I had Atapuerca here, but I don't. But the Atapuerca fossil, for example, Homo heidelbergensis, has more mid-face prognathism. So more in the maxilla and zygomatic region. All right, so, and again, these fossils are a mosaic. They're considered, this one's viewed as a mosaic of Homo erectus and Homo neanderthalensis-like traits. So remember, mosaic just means mixture of. So that term mosaic is coming up a lot. So mosaic just means mixture of primitive and derived features. So a mixture of older features in evolutionary terms and those that are newer. Cranial capacity for this fossil is about 1,125 cc's, but the range for the species about 1,100 to 1,300 cc's. So just slightly smaller, just an inch, just a itty tiny bit smaller than us. All right, another example, Rhodesian man. So this is the one I have right here as your example. So this is the Broken Hill skull. This one was found in Zambia, and it dates to about 125,000 to 400,000 years before present. So again, a mosaic of features. This one has similarities with Homo erectus and Homo sapiens. So the Homo erectus-like features is really robust, double arch brow ridge, much more robust than erectus actually. Also, there's a sagittal keel. So remember, that's a feature we talked about with Homo erectus. So when you're looking at the skull this way, so this kind of keeling, it kind of looks like the bottom of a canoe. So the sagittal keeling, it's in a similar location to the crest. Just make sure you don't mix it up with the crest. I always say you can see the sagittal crest, but you have to feel the sagittal keel. So you can see the sagittal crest, but you have to feel the sagittal keel. And that always helps me remember it, and it kind of rhymes a little bit, right? So, and the feeling of the keel, again, I wish I had you guys in person, but you kind of take the palm of your hand and run it across the center of the skull. And it's kind of like a speed bump running down the center of the skull. Okay, so you can, it's so pronounced in this one, you might be able to see it a little bit even in Zoom. But the way I remember it, you have to see the sagittal crest, but you must feel the sagittal keel. All right, so the sagittal keel and the double arch brow ridge, obviously those are similar with what we would see in Homo erectus. And then the features that are more similar with Homo sapiens would be the more the vertical or gnathic or flatter face. So when you're looking at the skull from the side, you see it's a really vertical flat face, especially in this one. And then the larger brain, of course. So the cranial capacity of this fossil is about 1,300 cc's, which is just a scotch underneath what you'd see in modern day Homo sapiens, because we have a range between 1,400 to about 1,700. Okay, so mosaic of features. And it makes sense to me, actually, that this one has a mosaic between Homo erectus and Homo sapiens, because that's where you see Homo erectus and Homo sapiens emerge as well. So to me, it makes a lot of sense that this particular fossil was found in Africa, and you see kind of a mixture of Homo erectus and Homo sapien-like features. Any questions so far? Feeling good? All right, let's talk about the Neanderthals. All right, let's say this one together a few times. So you guys at home practice with me. This is Homo neanderthalensis. Homo neanderthalensis. And one more time, Homo neanderthalensis. Okay, so you may also hear them called the Neanderthals, but that TH in German is kind of a hard T, so the correct way to pronounce it is Neanderthal. So if you're just, if you're just talking about the Neanderthals, you would say the Neanderthals. But when you're pronouncing the whole name, you can say Homo neanderthalensis, or you can say Homo neanderthalensis. So these specimens really exist from about 300,000 years to as recent as 30,000 years before present. But what we know is the classic Neanderthal skeletons really exist between about 130,000 to as recently as 30,000 years before present, which is very recent in evolutionary terms. They did coexist with us, with Homo sapiens, for probably at least 10,000 years, possibly more. As we discover more and more evidence that Homo sapiens may have been around a little bit earlier than we originally thought, I think it's very possible that they even arrived in Europe a little bit earlier than we thought. So we know that they coexisted at least 10,000 years, possibly longer. Neanderthals are anatomical features. So we see a really large cranial capacity. Actually, on average, their brain size is larger than us. But their brain size ranges anywhere from about 1,200 to 1,700 cc's. They have this feature in the back of the skull. This was a Neanderthal skull here. So in the back of the skull, they have this kind of bun-like feature, this kind of bumpy region in the back on the occipital bone called the occipital bun. So essentially what that is this bun-like feature, it's the attachment point for the nuchal ligament. So the nuchal ligament, that's a ligament in our neck. So it's in our neck and it attaches to the back of our skull. And the purpose is it prevents our head from pitching back and forth too severely as we're engaging in bipedal running, jogging, hunting, all sorts of complex physical activities. So that prevents our head from jolting back and forth too much. So it makes sense. I mean, the Neanderthals are extremely robust, very muscular, likely engaged in dangerous hunting strategies and techniques. So it makes sense why they would need this really pronounced attachment point for that nuchal ligament, because they likely needed a very strong nuchal ligament. Other features, they have a wide nasal aperture. So aperture just means opening. They have a wide nasal opening, and that's to cool down cold air before it reaches your throat and reaches your lungs. So that's a cold adaptation, or an adaptation to living in cold weather. The Neanderthals existed during the last Pleistocene, or the last ice age. So they have all of these, a lot of their adaptations, a lot of their anatomical adaptations are cold adaptations. No chin, just meaning that, so this is the mandibular symphysis here, or the mental protuberance, or I should say lack thereof here. So with a Neanderthal, you're going to see that it goes vertical like this. And everybody feel your own chin. So when you start at your lower lip and then feel down, we have a mental protuberance or a protruding mandibular symphysis. So we have a true chin. Neanderthals do not have a chin. Okay. So that's a really good way to identify if you're looking at a Homo sapien, because only Homo sapiens have that protruding mandibular symphysis. Postcranially speaking, from the neck down, Neanderthals have really massive long bones, really massive femurs and humeri. All of their bones are very robust, very thick, lots of rugose areas. Those are just the bumpy areas where ligaments will attach to the bone. So Neanderthals were extremely robust, very cold adapted. Thinking way back to what we learned with topic 5 in human adaptation, we learned about Allen and Bergman's rule. You guys remembering Allen and Bergman's rule? So if you're a cold adapted mammal, what is your basic body plan? Are you tall and lanky or are you short and stout?
Tall.
If you're cold adapted, if you're cold adapted, you're more likely going to be short, stout, and muscular. So thinking back to that ice bath example that we watched way back in topic 5, I know that was a while ago. So if you're cold adapted, you're more likely going to be shorter, stouter, more muscular. If you're warm adapted, warm weather adapted, you're going to be taller, lankier, and leaner.
Hmm.
Okay, so now of course there's some exceptions to the rule there, but in general, cold adapted mammals have shorter limbs and are more robust, more muscular, and then warm adapted mammals are lankier with longer limbs. Also, there is evidence, there's nuclear and mitochondrial DNA evidence that Neanderthals interbred with Homo sapiens. So we will talk about that in more detail later on in this lecture. But it is very likely that Neanderthals interbred with Homo sapiens when they coexisted with them and contributed to our modern day gene pool. So when you look at the genomes, when you study the genomes of modern day Europeans, Western Asians, Middle Easterns, those that have those descents from those regions of the world, Europe, Middle East, and Asia, tend to have between 200 to 300 Neanderthal haplotypes in their DNA. And that makes sense because that's where the Neanderthals existed. And then in comparison, modern humans that trace their ancestry to Africa, South America, Australia, tend to have a much smaller degree of Neanderthal in their DNA. All right, let's continue on. Questions so far? Okay, let's talk behavior, and then I'm going to show you guys some fun video clips. So one of the coolest things about looking at the fossils, looking at the species that existed more recently, essentially, is that we have more evidence of their behavior, and we have better ways of hypothesizing how these species may have organized themselves socially, how they would have hunted, the kind of tools they would have used, whether or not they had control of fire, et cetera, et cetera. So based on the evidence of the skeletal anatomy, we see that Neanderthals have lots of skeletal breaks. So lots of examples of broken legs, broken arms, broken backs, et cetera, et cetera. Sometimes it healed, sometimes it didn't. Because you can actually tell looking at the bone if the bone has healed or if it hasn't. If it's nice and smooth, then we know that that individual survived that break. If it's still really sharp and rugged, then we know that that break likely led to the death of that Neanderthal. But we see plenty of examples of both, plenty of examples of skeletal fractures that led to the death of that individual and some that didn't. So they likely engaged in dangerous hunting strategies. So they're living during the last Pleistocene where there's lots of large, dangerous game animals. Also, their hunting strategies. So they likely hunted with their Mousterian tips on the end of wooden shafts. So that required them to be very close to dangerous game. Whereas in comparison, Homo sapiens likely had the control of basic bow and arrow. So they could stand farther back and hunt something off in the distance, for example. It was once thought that Neanderthals were very carnivorous in the sense that they focused mainly on hunting dangerous game. But more recent studies looking at dental calculus, so basically Paleolithic dentistry, so they're able to extract the calculus or the tartar from the teeth and then examine that in great detail and do radiometric and carbon analysis and look at essentially what those organisms were eating. So based on the dental calculus, Neanderthals were, of course, they were eating a good percentage of protein, a good percentage of meat protein. But they also ate plenty of plants as well. So just like any other hominin, they're very omnivorous. They utilized Mousterian tools with the Lavoie technique. I'll show you a picture of that here in a moment. There's evidence that they cared for their sick. There's a very famous specimen called the Shanidar 1 specimen. So that specimen has an atrophied humerus, indicating that the lower arm, the lower part of the arm, the radius and the ulna was likely amputated. And we know that the individual survived this because at the amputation point, you can see that it's nice and smooth. So that individual had time for the bone to heal. So it's very likely that that individual social group was helping them survive, because you can imagine trying to survive during the last Pleistocene, the last ice age, trying to hunt dangerous game for survival. It wasn't likely very possible without the help of your social group if you only had one arm. Neanderthals also have evidence for language. So that bone in our vocal tract called the hyoid, it's a U-shaped bone in the vocal tract that's really important for our anatomical capacity to create articulate speech or language. So the hyoid bone of a Neanderthal is almost identical to what you see in Homo sapiens. In addition to that, when they did the Neanderthal genome, when they mapped the genome, Svante Pablo mapped the Neanderthal genome. He found that the FOXP2 gene, which is also very important in language acquisition and production, the FOXP2 gene in the Neanderthal is almost identical to what you see in modern Homo sapiens. Also, another very recent study, so recent, in fact, I haven't had a chance to include it in this PowerPoint slide. There's a region in the brain called the Broca's area that's really important for language acquisition and production. And there's a study that's looking at this region. Obviously, we don't have the brain material, we don't have the soft tissue, but the skeletal structure, the cranial structure of this region of the brain is indicates that this Neanderthal had a developed Broca's area. There's evidence that they consumed plants not just for nutrition, but also for medicinal purposes. And there's evidence for symbolic expression. So that's the first couple video clips I'm going to show you. Neanderthals likely symbolically express themselves. There's evidence for pigmented and perforated shell beads that they would have used possibly as makeup kits or as jewelry. There's evidence that they possibly created cave art, that they symbolically and intentionally buried their dead, and all sorts of other implications. So let's watch a couple video clips that show you these examples, because it's a lot more fun when we can watch it, right? Do we have questions before I move on to some video clips? Anything about Homo erectus, Homo heidelbergensis, or the Neanderthals?
How tall were the Neanderthals?
I would have to look into that to give you an average, but I would say, I mean, they weren't significantly shorter than us on average. I'd say maybe I'd have to look into it before giving you a number, but I would say on average they're a little bit shorter than us, but definitely more robust and more muscular.
Oh, thank you.
You're welcome. Good question. Other questions? Okay, so this first clip here, this is going to be evidence that they utilize pigmented and perforated shell beads. So this is a study done by Zalao at a site in Iberia. And we're watching a couple segments from the First Peoples documentary. So this is a documentary that you will eventually watch the whole thing of. I'm just going to show you a few clips of it for right now.
What I find cool in this
And let me make sure I've got the sound properly adjusted here for you guys.
case is that we have something that bridges that 50,000 years between us and them. In this case, it's the same tool being used across all that time.
João Zalao thinks Neanderthals had talents that went beyond tool-making. They also had an aesthetic sense. They were capable of symbolic thought, using shells to mix up natural pigments.
There are several possibilities to explain this. One is that they painted the shell. They wanted it to be a different color from the original. The other is that they were using the shell as a container for something like body painting or makeup. In societies that lack identity cards or passports, body painting and personal ornamentation transmit information about who you are. It's a way of conveying a message about themselves, which tribe you belong to, whether you're out to participate in hunting. In a way, you can say that this is modern behavior. And since we have documented it among the Neanderthals, the conclusion is that Neanderthals were more than two. That would be my conclusion.
What else were the Neanderthals capable of? Just how similar to us were they? Jean-Jacques Hublin is an expert on a layer of artifacts known as the Chattel Peronian from the early days of contact.
This is a tooth of fox that is pierced here, and we imagine very easily how this could be a part of a necklace, or how it could be fixed on a piece of clothes, for example. And clearly this speaks to us, because this is exactly the kind of technique that has been used by recent hunter-gatherers, and even today.
Archaeologists always thought of jewelry as the work of modern humans. But when they discovered the teeth of the people who made the artifacts, they were Neanderthal.
The teeth from the Chattel layers, they are typical from what we find in Neanderthal dentition everywhere else. You can see here the difference between a Neanderthal upper incisor and a modern human upper incisor. There's a difference in size. There's also a difference in shape. In Neanderthals, you have what we call a shovel shape of these tooth that you don't have at all in most modern humans.
If Neanderthals were making some of the first necklaces in Europe, what does this say about them and their abilities?
For decades, science has been asking itself the question of whether Neanderthals could or could not make these kinds of things as a clue to whether their cognition was like our own. It has become clear from the archaeological record that they could do these things. We know they could because they did do these things.
It seems Neanderthals were not the dumb brutes of legend. Isolated in Europe for tens of thousands of years, they had developed their own culture, on a par with that of their modern human cousins. But all the while, modern humans continued pushing out of Africa, through the Middle East, and into Europe. Change was coming. Within the Chattel Peronian layer, archaeologists find a type of spear point made by Neanderthals, which looks incredibly similar to points made at the same time by modern humans. It's as if the Neanderthals were copying the design. They may never have met the people who made the originals. All they needed was to find a discarded spear and work out for themselves how to make it.
It looks like they have produced the same kind of object, but with their own technology. So the final product looks very much the same, but the method to produce it is different.
To copy a technology without an instruction manual is a sign of intelligence. But it also spelt the beginning of the end for the Neanderthals. They were now playing catch-up. Their culture transformed by the presence of modern humans.
Some have argued that Neanderthals invented these kind of objects independently from the modern humans, but it's kind of puzzling that they would do that just at the moment when modern humans moved into Europe.
Something similar happened 400 years ago when Europeans brought horses to North America. The native people realized.
All right, so we're going to go ahead and pause there, but don't worry, you will have the opportunity to watch the full documentary for your discussion next week. But that one, I like that little clip right there because it gave you a couple of examples of how sophisticated Neanderthal technology actually was. Neanderthals were once given kind of a bad rap. They were considered to be primitive, dumb, brutish. There's even recent commercials that kind of poke fun at Neanderthal. The Geico commercials, so easy a caveman could do it. I don't really watch that much regular TV anymore, so I don't know if they still have them or not. But they, in recent memory, they were even still poking fun at the Neanderthals. But there's a lot of evidence that Neanderthals were just as sophisticated as we are. Maybe they just had slightly more specialized strategies for existing in the Pleistocene. All right, so these are their tools here. These are the Mousterian tools. Very beautiful, very sophisticated tools. Very difficult to recreate. So paleoanthropologists that try to recreate these stone tool technologies often find that it's very difficult to do. So there was obviously a lot of learning that went on with the ability to create these tool technologies. So likely something that was passed down from generation to generation and took lots of learning, lots of technique. And these are called Mousterian tools. And then also the Châteauperonian. The Châteauperonian tools are also associated with Neanderthals. That's kind of a transitional industry between Mousterian and then the later Paleolithic tools that we'll see with Homo sapiens. We'll talk about those next week. But think Mousterian Middle Paleolithic, and M is next to N for Neanderthal. So I remember Mousterian tools are Middle Paleolithic, and they're associated with the Neanderthals. So I mentioned that they likely utilized very dangerous hunting techniques. So I apologize for the kind of wonky picture here, but I picked it just because I wanted to show you, the evidence does show that Neanderthals were likely hunting with their spear points on the end of wooden shafts like this. So, it wasn't just mammoths that they were hunting, but just larger bovids, larger hooved animals. So the requirement of being very close to these animals likely resulted in a lot of their injuries because the skeletal remains of the skeletal remains of the Neanderthals that we find are oftentimes compared to modern day rodeo riders. So we know that whatever they were doing, they were engaging in dangerous activities, that they were oftentimes getting skeletal fractures. Sometimes it healed, sometimes it didn't. So we know that Neanderthals were likely engaging in something dangerous, and it was likely hunting strategies. So the difference, one of the hypotheses we always want to understand, okay, well, why are Neanderthals no longer here and we are? And we're finding that the answer may be that they are still here. They're just within our genomes, within our DNA. But at least we don't see the classic skeletal form of a Neanderthal in modern day. So one of the hypotheses is that Neanderthals had more dangerous hunting strategies that oftentimes resulted in death, and also that their dietary breadth was too narrow. So this kind of always reminds me of the robust versus gracile Australopithecine discussion, because as we've learned, the robust forms had a very specialized diet. They focused in mainly on rough, tough food items like vegetation, underground tubers, things like that, whereas the gracile forms likely ate a more varied, diverse diet. So one of the theories out there is that Neanderthals were too focused in on animal protein, that they were consuming mainly terrestrial protein sources like bovids, like hooved animals, whereas Homo sapiens were consuming a wide variety of things: plants, fruits, vegetables, meat, and even aquatic sources. And that's also kind of an outdated idea, because now as we're looking at the dental calculus of Neanderthals, and we're looking at stable isotope studies, we're finding that, yeah, that meat was important to the Neanderthals, and they likely ate a lot of meat, but they were likely not eating only meat. They were likely eating other things as well. So this is that Shanidar-1 specimen I was telling you about. So this is the humerus here. That's the bone in our upper arm. So you're seeing here that this one looks completely normal. The proximal and the distal end look completely normal humerus. But when you look at this one, it's severely atrophied. So you can tell even from this picture that the bone, it's thinner. But all the little rugose areas are smooth and they're healed. Okay, so this individual likely had his lower arm, his radius, and his ulna completely amputated, and probably part of the humerus as well, part of the distal end of the humerus. So this individual survived, because if he didn't survive, we would see really sharp edges here, not these nice smooth edges. So we know that this individual survived probably for many years after this injury. So again, it's all just hypothesis, but it's very likely that Shanidar-1 was able to survive simply because his social group helped him survive. Because if you're trying to survive in the Pleistocene, relying on hunting dangerous game, not always being able to rely just on gathering, if you're, during those periods where there may not be a whole lot of vegetation or fruit available, you're likely relying pretty heavily on your ability to hunt. So it's very possible that the only reason Shanidar-1 was able to survive is because his social group helped him do so. So Shanidar-1 is oftentimes used as evidence that the Neanderthals were compassionate for one another, that they placed value in every single member of the group, and that they helped each other survive. All right, there's lots of examples of symbolic burials in the Neanderthals. Your discussion for this week, we're going to look at Homo naledi, and we're going to look at whether or not Homo naledi possibly also had symbolic burial. I don't want to give too much away, but I will let you know that it is controversial that Homo naledi did in fact have symbolic burials. I haven't completely made up my mind one way or the other. But that's one of the many things I love about this field. We haven't completely uncovered all the answers yet. We're still in the process of doing so. But with Neanderthals, most paleoanthropologists would agree there's pretty solid evidence that Neanderthals had the capacity for deliberate, intentional, symbolic burials. And that may not seem like a big deal to us because, yeah, we do that all the time. We do. Obviously, there's variations in the way we do it from culture to culture, from ritualistic practice to ritualistic practice. There's variation, of course. But we all human societies in some way deliberately, ritualistically, symbolically, religiously bury their dead. But we see the first evidence for this in any sort of modern capacity with really the Neanderthals. And of course, possibly Homo naledi, but that's debated. We see some evidence of it with Homo heidelbergensis, but that's more of kind of a mass burial situation. But with the Neanderthals, we definitely see lots of examples, I think over 20 examples of individuals that are buried in this flex body position and also left with essentially grave goods. So there's evidence that they were left with tools, they were left with flowers. So essentially they're thinking about, what happens to our dead once they pass. They're really starting to think about the afterlife possibly. Again, that's, this is all speculation, all hypothesis, but when all of a sudden you start to see this change in the fossil records, you're not seeing evidence that these remains are just left where they died naturally and the natural processes deposited them in the fossil record, and that's how we found them millions of years later. With the Neanderthals, we're seeing evidence that their social group intentionally and deliberately buried them in a certain position and left them with grave goods. So, you could hypothesize that this is the point in time where we started to ponder what happens after the physical life, after our physical body has died. What happens to our soul? What happens to that part of us? So, again, all just speculation, but it's fun stuff to think about. And it also starts to connect with other parts of anthropology. Those of you that are interested in culture anthropology and the magic, witchcraft, and religion course will probably find interest in this as well. So there's plenty of examples. I believe about at least 20 examples of deliberate burials associated with Neanderthals. The La Ferace site is very famous one. That one's dated to about 65 to 70,000 years before present. The Shanidar site also has some evidence for intentional burials. The Kabara site in Israel. There's quite a few. I'd have to pull out my notes to name all of them for you, but there are quite a few examples of these deliberate, symbolic, ritualistic burial practices. All right, the Kabara Neanderthal, that one is significant because there was a large percentage of the skeleton uncovered, thankfully, a large percentage of the postcranial, and also the hyoid bone. That's that bone in the vocal tract. It's a U-shaped bone that's really important in reconstructing the capacity for language, the anatomical capacity for creating articulate speech. So the hyoid bone of the Kabara Neanderthal is almost identical to what you'd see in a modern human. I mean, of course, it's a little bit thicker, more robust because Neanderthals were more robust. But at least anatomically thinking, most paleoanthropologists agree that Neanderthals had the capacity to produce articulate speech. Now, of course, we can't go back 30,000 years and have a conversation with a Neanderthal, so we don't know if their language was less sophisticated or more sophisticated. In my opinion, it was probably just different, just like we have thousands of different languages, hundreds of different languages today. It was likely just as sophisticated, just different than ours. The Neanderthal Genome Project. So this was a huge undertaking. Svante Pablo and colleagues back in the early 2000s. I believe they originally came out with their results in 2010. I was in grad school at the time, and it was a huge deal. The Neanderthal Genome Project analyzed 21 Neanderthal specimens from the Vinja Cave site in Croatia. And they compared the results of this DNA study to modern day humans, modern day Europeans, Asians, Africans, Australians, all across the globe. And what they found is that the Neanderthal specimens, their DNA was more similar to what you would see in a modern day European or Western Asian. So those that can trace their ancestry back to Europe, the Middle East, and Western Asia are likely going to have more Neanderthal haplotypes in their DNA than, say, somebody that can trace their ancestry to Africa or Australia or South America. Which makes sense because the Neanderthals existed in Europe, the Middle East, and Western Asia when they were around. So this genome project provided pretty significant evidence that there was at least some degree of interbreeding. So that period of time where Neanderthals and Homo sapiens coexisted, there was at least some degree of interbreeding, according to this study. Okay, now, of course, in science, more evidence is needed. So, of course, as we continue to discover more and more specimens that belong to the species Homo neanderthalensis, more and more DNA studies are needed. And the thing about DNA, it does degrade over time, and it can get contaminated by bacterial DNA. And once a bone fossilizes, once it's completely fossilized, it's very unlikely that any DNA will be able to be extracted. At least with modern day technologies. That's not, I won't say that it won't ever be possible, but at least in modern day, it's pretty impossible to extract DNA from, fossils that are older than a few 100,000 years. Okay. It's not impossible. I'm not saying it's completely impossible. It's just in modern day, it's somewhat impossible. But that's why when you're looking at Neanderthals, many of these fossils are within the date range that they're not completely fossilized yet, and that DNA can be extracted successfully. Okay, so there is definitely evidence that Neanderthals and Homo sapiens possibly interbred and created viable, fertile offspring. So another callback, and we're going to go even farther back in the semester now, way back to topic 4, when we talked about the species concept. So the biological species concept basically states that in order for two organisms to be considered the same species, they must be able to interbreed, and they must be able to produce viable, fertile offspring. So, for example, the tiger and the lion, they may be able to produce one generation, but that liger, I know, super technical term, that liger is generally sterile, meaning that liger cannot then go on and produce another generation. Okay, so same thing with ostriches and emus, with horses and mules, et cetera, et cetera. There's many species that, seem like they're very similar, but when you try to have them interbreed, Sometimes it doesn't work at all. Sometimes they don't even produce one generation, but sometimes they can produce one generation that's not viable, not fertile, essentially. But with Neanderthals and Homo sapiens, there must have been at least a handful of cases that were successful. Because if they were not, we wouldn't see that the Neanderthals would still be in our genomes 30,000 years later. Okay. So the degree of interbreeding, the degree of successful events is debatable. But I think it's, it's pretty solidified at this point that there were at least a handful of cases that were successful. So the reality, what that means is that we may need to rethink the idea that Neanderthals are completely separate species from us, that maybe Homo neanderthalensis is merely a subspecies, or subspecies just doesn't mean less, it just means a kind of an offshoot. Or a geographical variant of Homo sapiens, okay? Because if we were able to produce viable fertile offspring with them, then they're not necessarily completely separate species. And we'll talk more about that next week. Next week, we're going to get into, we'll talk about Homo sapiens, and we'll talk about some of those enigmas, Homo floresiensis and Homo naledi. And then we'll also talk about the big theories on modern human origins. We'll talk about out of Africa versus multi-regional continuity versus the more recent assimilation model. But I do want to give you guys a little bit of time. I know I gave you a lot of information right there. So I do want to give you guys a little bit of time. Let me go here and stop our recording for now.